Hello all, welcome to my YouTube lecture. In this session, we are learning about behavioral modeling loop statements. We have four in kind: while, for, repeat, and for where loops. In this session, we concentrate on while loop. So while loop, uh, the keyword used is while, and this is much similar to the while loop that we normally use in C programming. The while loop executes until the while expression becomes false. To explore it, I have taken one example. In this example, we are trying to increment a count from 0 to 127, exit at count 128, and display the count variable. So this is a problem statement given to us. I'm just taking a piece of code here, declaring count as integer, and I'm using an initial block. Initial begin, because I have a multiple statements. I'm initializing count is equal to 0. So I'm putting a condition. While is a keyword. Here from here, the while statement starts. From here to here, while begin, and these four lines are while statement. It will check for the condition whether the count has reached 128 or not. If it has not reached 128, then the following statement will execute. What are the two statements? Dollar symbol display. Count will be displayed. Percentage D is used for integer display. So it will display the count. And the next statement is count goes on incrementing. So two things are happening here once it enters the while loop, displaying as well as incrementing. So this process we shall observe in a Verilog simulator. So I have taken the code. The module name is count underscore mod. So here I have declared count as integer. Same code. You can see only one change between the one I have taken on the slide and here. I've introduced this delay #5. So when count is equal to count plus 1, it is incrementing. If I don't mention this delay, then this counting happens in 0 simulation time. Within 0 simulation time, count reaches 128. Practically, it is not possible, whereas theoretically anything can be possible. So in order to add some practical aspects to it, I have introduced a delay. After every 5 time units, count is incrementing, and you will display that value using a dollar symbol display. So here, one more thing I want to make you clear. Loop statements are not meant for design block. Loop statements are normally used for writing stimulus block, writing test bench, not for design. For design block, you can use, but it is not recommended to use the loop statements. Please keep in your mind whenever you write a Verilog program. Now we will simulate it, simulate the same, and we'll check. So up till 128, count reaches 128, it has to increment. Once it reaches 128, it should come out of the loop. So here you can see, I just maximize zoom to fit. I just zoom it. I keep it in radix and unsigned decimal, because when you declare it as integer, it will treat it as 32 bits. So 0, 1, 2, 3, 4, 5 till it continues till 127. So once it reaches 127, it will come out of the while loop and it will have 128 continued thereafter. And you can see here, as I have given 5 nanoseconds of delay, at every 5 nanoseconds it is getting incremented. If you don't produce this at 0 simulation time, all this happens and you will not be able to see all these things. Now we have one more code for loop statement, while statement. So here the problem statement goes like this: find the first bit with a value 1 in a flag. So here we are defining a flag register of 16 bits. I'm defining integer I just for some usage, indexing purpose. I'm defining continue register continue. Here's the initial block, initial begin. I'm initializing flag with 16 bits. Here the intention of us is the first bit with the value 1 should be detected, and the count starts from here. If I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14th bit is the value, first bit with a value 1. So 14 should be the output of this code. Let me check how it can be done. So I is initialized as 0, continue is initialized as 1, while I is less than 16. Why I has been less than 16? Because it is for indexing purpose. Indexing means to represent a particular bit. How many bits are there here? 16 bits. 16 is the maximum. So I am starting it with 0. Hence, I'll end it with 15. 0 to 15 will be 16 bits. So 16 is a maximum number. Ampersand, logical ended with continue. If continue is 1 and if this condition is satisfied, then only while loop will be entered, or else it will not enter it. Begin. If flag of I, this means flag is a 16-bit register. I's current value is 0. Flag of 0, it means this bit it is taking care now. So this bit it is checking if I don't write double equal to 1, if I don't write double equal to 0, it doesn't matter. If you just write flag of I in if statement, then it is as good as writing flag of I double equal to 1. By default, it is considered as double equal to 1. So it will check whether the least significant bit is 1. If so, it will enter the loop and it will display that encountered a true bit element, and continue is made as 0 so that it should not enter the loop again, and then increment I. If this is not entered, then I will be incremented. This is what happens. And once I is incremented, flag of 1 it will check. If it is 1, this will be executed. If it is not 1, I will be incremented. So once it encounters the first bit with value 1, continue will be set to 0. When continue is set to 0, it is logical ANDed. When logical ANDed with 0 will always result in 0. So while loop will not be entered. That's a termination of your code. So let us check the same code in the Xilinx environment to explore the understanding of it. I have considered the same code. I have declared the register as CONT rather than continue. Both are same. Everything else is same. And we can say that the first value with first bit with the value 1 is at, if I start counting from 0, it will be 13, 14, 15, 13th. 13th bit is made 1. My answer should be 13. 13 should be displayed. And after it displays 13, it increments by one more time. It becomes 14. Let us not worry about it. 13 is our value. When it completes the program, it would have become 14. But displaying will be correct. I value would have incremented by 1. Let us check whether the same thing is happening or not by simulating it. So again, you can check. I have not defined any inputs and outputs because the loop statements are not recommended for design blocks. If you are designing a block or circuit, then you'll be having inputs and outputs. If you're writing test bench, you will not be having any inputs and outputs. So here you can see that I just read it as unsigned decimal. 14 is a value, 14 bit. One time extra it has incremented. So at 13th bit it has detected the value, the bit with value 1. That is what has been displayed here. You can check it here. This is how it displays. When you use a dollar symbol display command, system task, it will display in the console. Encountered a true bit at element number. So you had given some space 13. At 13 bit, number 1 is encountered. So this is how you can just verify the output of it. And see you in the next video for more examples on loop statements. We'll take for loop in the next session. Thank you.